morning. Today we are going to be presenting about our topic, obstacle avoiding robot using Arduino. Myself, Shankar, have teamed up with Naveed to present this project. So before we start, let's go over what all topics I'm going to be covering. We are going to cover in this presentation. That is introduction, the objective of the project, the literature review, what methodology we have used, the hardware components and software which we have used for the project, as well as our final work. And then we are going to sum it up with a conclusion as well as the references we have used for the project. So let's start off with the introduction. An obstacle avoiding robot car is a type of autonomous vehicle that is capable of navigating around obstacles in its environment. It is equipped with sensors that detect obstacles in its path, and its control system uses this information to determine the best path to avoid the obstacles. The car is programmed to respond to its environments in real time, making decisions on its own to avoid obstacles. Obstacle avoidance is a critical capability for autonomous vehicles, particularly those operating in urban environments where there are many obstacles to navigate around. The obstacle avoiding robot car technology has the potential to revolutionize transportation by reducing the risk of accidents caused by driver error and increasing the efficiency of traffic flow. Next, let's talk about what the main objective of the project is, and that is to design and develop an obstacle avoiding robot that can navigate in a suitable environment while avoiding obstacles in its path. The robot should be able to detect obstacles using sensors and, after processing the data, take appropriate actions to avoid collision. So this is the literature review which we have used for the project. These are some of the few papers that we have referenced to make our project, and this is the observations and the key point which we have taken from them are: we are using an ultrasonic sensor to detect the obstacles, and we are using Arduino code which is used to help avoid the obstacles. So now let me go over the methodology of the project. So the methodology for designing an obstacle avoiding robot is: first we assemble the robot chassis by attaching the wheels and TT gear motor to it. Then we are connecting the TT gear motor to the motor driver shield and Arduino Uno using jumper wires. Then we finally connect the lithium-ion battery to the motor driver shield. We then connect the ultrasonic sensor to the Arduino Uno using jumper wires. The ultrasonic sensor has 4 pins: VCC, ground, trigger, and echo. First, we connect the VCC and ground to the 5-volt and ground pins of the Arduino Uno respectively. Then we connect trigger and echo to any 2 digital pins of the Arduino Uno. The program of the Arduino Uno to read the distance data from the ultrasonic sensor and control the TT gear motor's movement accordingly. For example, if an obstacle is detected within a certain distance, the robot will turn to avoid it. Using a servo motor to provide a 360-degree view for the ultrasonic sensor, we are then connecting the servo motor to the Arduino Uno using jumper wires. We then program the servo motor to rotate the ultrasonic sensor in a 360-degree range. And finally, we are adding a DC power switch to the circuit to turn the robot on and off. Now I'm calling my friend Naveed to present the rest of the topic. Thank you.
Good morning. I am Naveed. Now I am going to. This is our circuit diagram for the for our project, the Arduino robot, which is an obstacle avoiding robot. It has various components such as lithium-ion battery and TT gear motors. There are 4 motors. There is a servo motor which is used for 360-degree rotation of the ultrasonic sensor in order to detect the obstacles. This is connected to the Arduino, present in the motor driver shield. That's all. I will ask my friend to proceed to the next slide. Now let's discuss on the hardware parts. Those are Arduino Uno, motor driver shield, wheels and TT gear motor, which are 4 in number. Then servo motor, one servo motor which is used for the 360-degree rotation of ultrasonic sensor. Next is the ultrasonic sensor itself. Next is we need 2 lithium-ion batteries and jumper wires. The software used for this for coding is the code is written on Arduino IDE. It also has a DC power switch. Next are the applications of Arduino. This robot. They are industrial automation, military and security, research and development, agricultural automation, delivery services, exploration and mapping, and household appliances. Next, I will proceed on to the conclusion of our project. Our project is aimed to develop an object detecting and avoiding a robotic car using an ultrasonic sensor and Arduino Uno. The objective was to create a robotic car that could navigate its environment and avoid obstacles in real time, demonstrating the potentials of autonomous vehicles and robotics. Object detection and avoidance are critical capabilities for autonomous vehicles, industrial automation, and search and rescue missions. Our project highlights the importance of this technology and its potential to revolutionize these industries. We encountered challenges during the project, including issues with the accuracy of the ultrasonic sensor and the car's control system. However, we were able to address these challenges and successfully demonstrate the car's object detecting and avoiding capabilities. Future improvements to the project could include incorporating additional sensors such as infrared or LiDAR sensors to enhance the car's detection capabilities. We would also optimize the car's control system to improve its efficiency and speed over the time. We could also add voice control settings to the car. The technology developed in this project has potential real-world applications, including autonomous vehicles, industrial automation, and search and rescue missions. Our project demonstrates the potential of this technology to revolutionize these industries and improve efficiency and safety. These are the references for which by which we have referred for this project. Thank you. We'll be adding the working and the explanation of the code in the next video. Thank you. Good evening, everyone. I'm going to explain the code for the obstacle avoiding robot now. At first, we have included the library to control four motors via the motor shield, which is afmotor.h. Next is we have included the library newping.h to send and receive the ultrasonic ping of the ultrasonic sensor. Next, we have included a library file called servo.h to set the servo motor angles. Next, here have defined the trigger pin to be A0, echo pin to be A1, and the maximum distance to be 200 centimeters, the and we have set the maximum speed of the DC motors to be 190. Next, we have set the maximum speed offset to be 20. Next we have created a function sonar with the parameters trigger pin, echo pin, and maximum distance. Next we have declared three or four motors with the frequency of 1 kilohertz. Next is we have created an instance of function servo with the name myservo. Next we have set set a goes forward variable of boolean type to be false in order that the car doesn't go forward in the beginning in the start. Next we have initialize the distance variable to be 100 centimeter uh, and initial speed to be 0. Next we have declared a setup function. uh, um, then uh, we have um, we have called a function attached using the instance myservo uh, from pin 10. Next we have wrote onto the we have set the servo angle to be 115 degree using the right function of the using the instance myservo. Then we have created a delay of 2 seconds. Then we have used the read ping function to measure the distance from ultrasonic sensor and the nearby object, and passed on to the distance variable. Then we are going to create a delay of 100 milliseconds. uh, then we are again calling the read ping function to detect the distance and store it in the distance variable. Then we are calling the delay function again to create a 100 millisecond delay. Then again we are gonna read the distance. We are gonna repeat it for one more time. Next we are gonna declare a loop function in which at first we are initializing the right distance to be 0 and left distance to be 0. Then we are going to call a function delay of 40 milliseconds, and next we are going to add an if condition, with the condition that if the distance is less than or equal to 15 centimeters, we are calling a move stop function, which detects the distance between the car and object, and if it is less than 15, it stops the car. Then we are going to call a delay of 100 milliseconds and move the car backwards using the move backward function. Then we are going to call the delay. We're going to call a delay of 300 milliseconds using the delay function. Then we are going to call the move stop function to stop the car. Then we are going to call the delay function call a delay of 200 milliseconds again. Then we're going to call look right function, which checks the distance to the right of the ultrasonic sensor and stores in distance r variable. Then we are going to call a delay of 200 milliseconds again. Then we are gonna store the distance of the left of the ultrasonic sensor and the nearby object and store it to the distance L variable. Then we are gonna call the delay of 200 milliseconds again. Then we are gonna check if the right is greater than or equal to distance at the left. If so, we are gonna turn right using the turn right function. Then we are gonna stop the car. Else, we are gonna turn left and stop the car there. And further else, we are gonna move forward. If both of the conditions doesn't satisfy, if that it will move forward. Next is we're gonna read the distance from the ultrasonic sensor and the nearby object and store it to distance again. And next, we're gonna define the look right function. By At first, we are gonna write the angle of servo motor and store it using the right function as 50 degrees. Then we are gonna call the delay of 500 milliseconds again. Then we're gonna measure the distance of the ultrasonic sensor and the nearby object and store it to the distance variable again. We are going to update the distance variable here. Then we are going to call the delay of 100 milliseconds again and set the servo angle as 115 degrees and return the distance return distance as the returning variable of this function. Then we are going to define the look left function. At first, we will set the angle of the servo motor to be 170 degree and call a delay of 500 milliseconds. Then we're gonna read the distance between the nearby object and the ultrasonic sensor and update it to the distance variable again. And then we're gonna call the delay of 100 milliseconds and set the servo motor angle to be 115 degrees and return the distance variable and call a further delay of 100 milliseconds. Then we're gonna define the read ping function. Set at first we will set a delay, call a delay of 70 milliseconds, and then get the distance in centimeters from the sensor and store it in cm. If cm is equal to 0, then update the value of cm to be 250 and return the cm. Then we are gonna define the function move stop. At first, we will call a run function using the instance motor one, and we will pass release as the parameter. We're gonna release the TT motor one from the connection. Similarly, we'll release motor 2, motor 3, and motor 4. Then we're gonna define the move forward function. If it is not going forward, not if the goes forward variable is false, we'll set the goes forward to true, and we will run all the four motors to forward direction. Then we are going to start a for loop, which it is to slowly bring the speed up to the maximum speed to it will slowly bring the speed to maximum speed as it will reduce the load on the batteries, and it will reduce the draining up of batteries quickly. Then we are gonna set the speed of the motor to speed set value. Similarly, for motor 2, motor 3, and motor 4, we will set the speed to be the speed set value. Then again, we are going to call a delay of 5 milliseconds. Then we are going to close all the functions. Next, we are going to define a move backward function. Initially, we will set the goes forward value to false. As it will be, if the car is moving forward, we will stop the car. As it goes forward, variable will be turned to false. Then we'll set all the motors to run to backward using the run function. Then we'll similarly call the for loop to bring the speed up slowly, and we'll increase the speed. We'll set the speed for all the motors to speed set value, and we'll call the delay of 5 milliseconds again. Next, we are gonna define turn right function. At first, we'll set all the motors to run forward. Then we'll call a delay of 500 milliseconds. Then we'll again set all the motor to run forward. Then we'll define turn left function, and we will set all the motors to run. Motor 1 and 2 to run backward, and motor 3 and 4 to run forward, and set a delay of 500 milliseconds. Then we'll set all the motors to run forward again. By this, I'll conclude my explanation of the code. Thank you for listening to me patiently.
Morning everyone, I am Naveed Mohammed and this is Shankar Jyothish. We have teamed up to make an obstacle avoiding robot. Now I invite my friend to explain the components of the robot.
Yes, so I'm going to be explaining the components of this obstacle avoidance robot. So first up, we have the motor shield here, which is used to run the servo motor as well as the gear motors. We have 2 lithium-ion batteries here, which is used for the power supply. And then mainly we have the ultrasonic sensor here, which is used to detect whatever object is in front of us. We have 4 wheels, which is used to run the car. We have a servo motor here, which is used to change the direction of the ultrasonic sensor, as well as 4 gear motors, which is used to accelerate the car. Plus we have an Arduino Uno at the bottom, which is where we provide the code and how the obstacle avoidance robot works. These pins are where we connect the gear motors. This is where we connect the servo motor, and these are the analog pins which are used to connect the ultrasonic sensor.